Okay, good afternoon, ladies and gentlemen. Today we start empirical formula, but I would just like to revisit the last question that we were doing uh, in the previous lesson, which was unlike soaps, detergents work very well in hot water. Now, how do you explain this? So, if you have done your research, and you would have an answer similar to this. Detergents would have similar hydrophobic and hydrophilic paths. However, their hydrophilic end does not form a precipitate with calcium or magnesium ions. And since hard water is rich in calcium and magnesium ions, um, they work reasonably well in hard water as they will not form any precipitates with calcium or magnesium. Another key thing that I want you to note about detergents is that detergents are usually cheaper per kilogram compared to soap per kilogram, and you could check this anytime you go to Coles or Woolworths or any place where you buy your household needs. That per kilogram, if you check the price of soap, it will be at about 6-7 times as high as per kilogram if you buy detergent. Detergent's cheap, and the reason is that you need petroleum products. You need petroleum products and sulfuric acid. Sulfuric acid is really cheap, and petroleum products are cheap. You need a combination or a reaction between petroleum products and sulfuric acid to get detergents. But uh, for soaps, you need animal fats, which are animal fats or vegetable fats, which are relatively expensive. So that is the reason that soaps are usually expensive, more expensive than detergents. With that being, with that done, today we move on to the next topic, which is empirical formula. Okay, so empirical and molecular formulas. Now, this is the first question, just a quick review of what we learned in year 11. And all it's asking you to do is you need to write the molecular and empirical formulas for the following compounds. Now, if you do not know what an empirical formula is, that's fine. But at least write the molecular formulas for these compounds given below. So dinitrogen tetroxide, oct 3-ene dioic acid, glucose, ammonia, and ethanoic acid. So I'll just zoom out so that you can see all of them. So have a go through these, and then I'll show you. If you do not know what empirical formula is, if you don't remember, I'll just go through it with you. So I'm going to start off with the molecular formulas. For dinitrogen tetroxide, the molecular formula would be N2O4. Di means 2, tetra means 4. This is how you name covalent compounds. Oct 3-ene dioic acid. If you're wondering what the structure would look like, draw an octane molecule. 5, 6, 7, 8. Oct 3-ene 1, 2, 3. That would be the third. And then dioic. Now you know that the carboxylic acid is given priority 1. You have dioic acids. So that means that you're looking at one acid group on the left and one acid group on the right. And then the rest would be hydrogens. Oct 3-ene dioic acid. But if I had to write down what the molecular formula would be, it would be C8. If you count the hydrogens, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And there'd be 4 oxygens, both arising from the carboxylic acid groups. All 4 arising from the carboxylic acid groups. Glucose is C6H12O6. No trouble there. And ammonia is NH3. And finally, you have ethanoic acid, which is just CH3 COOH. That's all good, but the question here is, what's the empirical formula? These are all molecular formulas. So what are empirical formulas? Empirical formulas is when you show the atoms present in a substance and give the simplest whole number value of those atoms. the simplest value. And how do I get the simplest value? I think of a number which would divide both to, for in this case, I would think of a number which would divide both 2 and 4, and that number is 2. Okay, so that would leave me with n 1 o 2, and the empirical formula therefore is n1o2. This is your empirical formula. It's the simplest whole number ratio. Now if I were to ask you, is there a number that goes into both 1 and 2? Is there one? Just one. So there actually, other than 1, there isn't any number. If I divide by 1, I'm going to get the same answer. That's the empirical formula then. It's the simplest whole number ratio between atoms of a molecule. So if you want to write that down, empirical formula is basically, EF is basically simplest whole number ratio between atoms. In this case, when you have C8, H12O4, what do you think would be the simplest whole number ratio between 8, 12, and 4? What would you divide it by? 4. And that would leave you with C4, C2, C2, H3O. Next one, glucose. What's the simplest? How can you write this as the simplest whole number ratio? What do you divide it by? 6. Thank you for that, Big T. You get CH2O. And finally, NH3. This one's a tricky one. What do you divide it by? 1. So you can't do much about it. The molecular and the empirical formula is the same. Same molecular formula as well and empirical formula. Finally, CH3COOH. In this kind of question, I'd suggest writing it as C2H4O2. Now you know what you need to divide it by. So what would you divide it by? So you end up with CH2O. That's it, done. Now, if you understood this bit, you should be comfortable enough to do question 1 from set 19, and it should not take you more than 4 minutes. 4 questions, 4 minutes is enough. So go ahead, give it a try. Okay, the next bit we'll go through is when we have empirical data available, how do we calculate empirical formula? Empirical data is the data that comes from experiments. So if we have those observations with us, can we actually determine the empirical formula? So if you're looking for a question that we're going to discuss here is example 2 from page 140 in your book. It says that analysis of a 3.625 grams of citric acid sample. So what is given to us? That's the first thing we need to write down. Given 3.625 grams of citric acid. That's given to us. It contains 1.36 grams of carbon. So amount of carbon is 1.360 grams. The amount of hydrogen is given to be 0.1522 grams. And finally, the remainder being oxygen. So amount of oxygen is unknown. However, since we know that the total mass of the citric acid is 3.625 grams, and we also know that the amount of carbon and hydrogen is given, we can easily determine the amount of oxygen here, which we just need to subtract the amount of carbon and amount of hydrogen. That would leave you with 2.113 grams of oxygen. Now this question is really straightforward after that. You know W of carbon is 1.360. So you can actually easily determine you can determine the number of moles of carbon, which would be 1.360 divided by the molar mass of carbon, which would be 12.01. Do the same thing for hydrogen. Number of moles of hydrogen would be 0.1522, 0.1522. Now in your book it says 1.522 for some reason. It should be 0.1522. So there's something wrong in your book. Did you notice that? Yeah, it's wrong. So be careful. In your book it says 1.522 in the second step of the solution, but it is actually 0.1522. It says it is 0.1522. So that's number of moles of hydrogen. And finally, the number of moles of oxygen is 2.113 divided by 16. If you work this out in your calculator, you would be getting 0.1132, 0.1510, and 0.1321. Now, how do you go after? What do you do after this? What you need to do after this is you have to find the lowest number of the three, decide on the lowest number of the three. So as you can see in these from these three, the lowest number is 0.1132. So you divide it by the lowest of the three. 0.1132, 0.1132, which gives us 1.333 and 1.166. But as you already know that the empirical formula is the smallest whole number ratio, this wouldn't work because this gives me C1 H1.333 and O 1.166. So that means that I will have to multiply it by a certain number so that every number is turned into a whole number ratio. So what do I need to multiply this and this with so that I get a whole number ratio? What do I multiply it with? 6. So if I multiply this with 6, 1.333 with 6, I end up with 8. If I multiply 1.166 with 6, I end up with 7. So I multiply everything with 6. And I will end up with 6. 1.333 times 6 is 8. And 1.166 times 6 would give you 7. So your final answer is C6H8O7. That's your empirical formula. Now, if you have understood this question, you should be comfortable enough to do question 2 and question 3 from set 19. If you have any doubts, I'll come and help you. Thanks. Okay, next bit. Now we'll go through example 3 together. So example 3 says that the analysis of a compound showed that it has 14.49% carbon. So the carbon percent is 14.49%. 47.05% potassium. So potassium is K, which is 47.05%. And finally, the rest is oxygen. So 100 take away 14.49 plus 47.05 is oxygen, which gives you 38.46%. Now, next thing, you would need to assume 100 grams of the compound so that we have the mass of carbon as W of C as 14.49 grams, weight of potassium as 47.05 grams, and finally weight of oxygen as 38.46 grams. Now what you could do after this is the same thing that we've been doing. Divide the weight by the number by the molar mass to get the number of moles, and then take the simplest whole number ratio. So I'll leave that question to you guys, and we'll continue, and you can practice questions 4 and 5 uh, after that. Thanks.